Hello and welcome to lesson number 3 in Unit 0, Algebraic Tools in our grade 11 University College math class. This is factoring part 2, factoring by grouping and tricky trinomials. So we're going to start by looking at factoring by grouping. Factoring by grouping is when you factor 4 or more terms by sort of like grouping them into discrete groups. Let's have a look. I've got one filled out here that we can sort of follow. So let me talk through this. If you would like to maybe pause here, copy this down, and then as I'm talking you can just sort of listen and watch along. So why don't you do that now? Okay, you're back. So we have a 4-term polynomial, x cubed minus 4x squared plus 3x minus 12. And what we're going to do is we are going to look at just the first 2 terms and we're going to common factor them. So that's what you see happening. Let me change up my color here. That's what you see happening right here. So if we've got x cubed minus 4x squared, if I were to common factor that, the greatest common factor in there is x squared. And when I common factor x squared out of x cubed, I'm left with an x. And when I common factor x squared out of minus 4x squared, I'm left with minus 4. Then I'm going to do the same thing to the second sort of artificial grouping that I put together here, where I've got 3x minus 12. And I'm going to common factor that. The greatest common factor is plus 3. And when I common factor 3 out of 3x, I'm left with an x. And when I common factor 3 out of negative 12, I'm left with negative 4. So what you'll notice now is we've got 2 terms again. This one, let me just change up my colors again. You've got sort of, this is our first term, x squared bracket x minus 4. Remember, that's a single term because those things are being multiplied. And then you've got plus 3 bracket x minus 4. So we have 2 terms. Now we're going to common factor again. And what you're going to notice is the greatest common factor happens to be that binomial that we factor that was the result of factoring the other stuff out. X minus 4, x minus 4. So we're going to write that as our greatest common factor, put that out front. And when we factor x minus 4, the bracketed x minus 4 out of the first term, we're left with x squared, and out of the second term, we're left with plus 3. And that is all we can do for this one. That's good old-fashioned factoring by grouping. So let's try one together. Let me grab the second example over here. Here we have 3ax minus 3ay minus 6bx plus 6by. So again, remember, we're going to try to just imagine we're going to cut this in half, and we're going to just focus on the first 2 terms out of the gate. So the first 2 terms are 3ax minus 3ay. So what's the greatest common factor here? It's going to be 3a. Now when I factor 3a out of 3ax, I'm left with just an x. And when I factor 3a out of minus 3ay, I'm left with minus y. So that is our first binomial factored. Now I'm going to focus on the second piece. And I want to make sure that you remember that negative in front of the 6bx, that negative is a part of the second half. So what is the greatest common factor in minus 6bx plus 6by? It's going to be 6b. But, and I want to make a note of this, when you have a negative leading term, I should write the whole word negative, I'm just being lazy. Negative leading term, when you have this negative leading term here in the second half, you are going to common factor out that negative. Common factor out the negative. Okay, which just means that instead of just factoring out 6b, we're going to factor out negative 6b. And when we factor negative 6b out of negative 6bx, I'm left with an x. And when I factor negative 6b out of positive 6by, I end up with negative y. And remember, proof of concept here is that if I take negative 6bx and multiply it by negative y, I end up with positive 6by, which is what I started with. Yeah, the sign changes, and that's just something to be mindful of. Okay, so now we've got 1, 2 terms, and we're going to common factor again. So what's the greatest common factor here? It's that binomial. It's that x minus y. And when I common factor x minus y out of the first term, I'm left with 3a. And when I factor x minus y out of the second term, I'm left with minus 6b. Now in this case, We're not quite finished yet, and the reason is because if you look at our resulting binomial here, there's actually a common factor that we can factor out. The greatest common factor to both of those terms is 3. And when I factor that out, I'm left with a minus 2b. Now this is probably not the traditional way to write it. I would say normally people tend to write the monomial out front, but it's not incorrect to write it the way that we did up above. Not incorrect, maybe just less commonly seen, but I would certainly accept that as a right answer. Okay, so that is factoring by grouping. Let's do a couple more examples here. Or I think just one more example actually. So here we have 3x to the exponent 5 minus 6x cubed minus x squared plus 2. Let's go for the first two terms. Let's look for our greatest common factor. It's going to be 3x to the exponent 3. And when I common factor that out of the first term, I'm left with x squared. And when I common factor it out of the second term, I'm left with minus 2. There we go. Let's look at our second two terms now. And again, we've got a negative leading term there, which means we're going to be factoring out a negative value. Now, interestingly enough, it doesn't appear that there's a common factor here between minus x squared and plus 2. However, 1 is always a factor that we can factor out if need be. In this case, a negative 1, which will leave us with x squared minus 2. And again, that proof of concept, remember, negative 1 times negative 2 will give us positive 2. So yes, the sign changes. It's just something we have to be mindful of. Okay, so we've done this. We now have two terms, this guy, this guy. Let's factor out the greatest common factor. It's the binomial, x squared minus 2. And when I common factor that out of the first term, I'm left with 3x cubed. And when I common factor it out of the second term, I'm left with minus 1. No other common factors in there, so that one's kind of finished. And as I say this, we're not actually going to do example D. The way that we've organized these, we haven't really done formally, at least in this course, differences of squares yet, which is something that we would need for this one. So we're just going to skip over D for now. If we can remember to come back to it, awesome. Maybe we never will. Who can say? Now, before we stop this video, we're going to do a quick recall on simple trinomials and how to factor them from the last lesson. So let's do that right now. We have here x squared minus 7x plus 12. How do I know this is a simple trinomial? We have a coefficient of 1 out in front of our x squared term. So what are we looking for here? We're looking for something that multiplies to our c value, so something that a set of integers that multiplies to positive 12, but when added together it gives us positive 7. And that pairing will be plus 4 and plus 3. And I will write those now in the brackets. So we have our two brackets. Because we start with an x squared, each of these brackets will start with an x. One gets a plus 4, one gets a plus 3, and that has been factored. Let's do one more. Here we have b squared minus b minus 30. So again, it is a simple trinomial. It has a coefficient out front of 1. We are going to now try to find the pair of integers that multiply to negative 30, but which when added together gives us a negative, it's invisible, but it's a negative 1. And the pairing that will do that, well, one's going to be positive and one's going to be negative. Negative 6 and positive 5. That will get the job done for us. So we get our brackets going. Starts with a b. One gets a minus 6. One gets a plus 5. Again, order's not important here. You can put b plus 5 and b minus 6 if you like. It doesn't really matter. So there we go. That is a quick recall on factoring simple trinomials. We're about to go off into the wacky world of tricky trinomials. We're going to save that for part 2 and probably part 3 if I'm being honest. It's a bit of a process to this one and I want to make sure you understand it really well. So we'll see you in part 2.